let me start at the CPP India Con 2021. We just have had that couple of weeks ago, and it was a super successful day-long exchange of knowledge of everything that is new. And it was really fulfilling, and we had some good exchanges. Even talk with Bjana, the keynote, all of those. I'm not naming any, to be fair to all. And so uh, the issue. So I thought maybe we were talking about a lot of new stuff. It was much of it was C++20 with talk about ranges, talking about concepts, even contract programming, which is not very well supported in C++ already, and it is in discussion in the committee right now. So I thought we could take a little light this time and perhaps look at the basics. Look at basics. What I'm going to talk about today might have nothing new for any of you, but these are all good, nice, healthy reminders which we sometimes forget about on the way. So that's the intention of the talk, making my intent clear. Okay. And that's where you can find me on these pages. So as requested, you can have your cameras open and please definitely pitch in with your thoughts as we discuss this. So who's this?
Robert Martin, aka
Okay.
Uncle Bob.
Uncle Bob.
So quick mute is Control Shift M if you guys want to quickly mute and unmute. So that's Robert Martin. He's written a lot about solid programs and clean code, etc. And he says that the ratio of time spent reading versus writing code is well over 10:1. You know, that's the amount of time that we think we are all 10x developers, super coders, and quick typing is how we are all portrayed when it comes to you know implementing, building, or doing our programming. But it's so not right. We have to look at the code. If you want to change something, you have to look at what you will impact. You will browse at least 10 files before you are able to be sure that what you are going to change and implement in an existing piece is actually the right thing and what it impacts really, and you're very sure that you have analyzed all of that. That is so true that it is 10 times that we read. And so it is very important that the code speaks to us, tells us, and lets us know what exactly it is about. Who's this? Someone?
Martin Fowler.
Yes. Good job, Himal. That's Martin Fowler. He says any fool can write code that a computer can understand, but good programmers write code that humans can understand. Okay, that's very much the point of the code. You communicate the code. Code is also a communication tool of what the product does. Okay, and I had to quote this. This is Tony Hoare from he is a Turing award winner, and in his lecture he has mentioned that there are two ways of constructing a software. One is to make it so simple that there are obviously no deficiencies, and the other is to make it so complicated that there are no obvious deficiencies. Okay, both are very sweet spots to be in. And so it's an art of how you implement and how it conveys things about itself. And it's a very difficult and tedious habit to have. It is all about your daily choices. Every line that you write is conveying something about your intent on what the thing is doing. And so it is very important that everything is thought through. And in the lack of time, we still want to be able to have these good habits of churning out code, which is making itself very, very apparent. Okay. So that's the point Tony Hoare is also making. And we want this a very, very desirable quality of our code. Code should be easy to use correctly and difficult to use incorrectly. You really have to fall in a bad place in order to use good code, good code badly. And it should be very easy to use the code the right way. It should be as one expects, as a newbie would expect. Code should be very clear on what it is doing, and so on and so forth. For example, I'm just giving this example inspiration from what a GUI is. In my opinion, the purpose of a GUI is to make the functionality of the application apparent to the user and enable good use of it. This is why a GUI exists. It just communicates what the application facilities are, what it allows you to do, and how you can use it and how you can use it well, how to expect the expected things at the right places, and not have any surprises, and also to communicate clearly well what the functionality is doing. These days we don't, user manuals are created, but do you want to read them? No. And that is exactly the same thing that we should have with our code also. We should not have to explain much. Yes, there are comments, but what you couldn't say programmatically, you will say well in English. What's the guarantee? Okay. So there's always a line. You should explain yourself. There are things which need explanation. Don't take me absolutely. The life is not black and white. And so that gets me to the next point, which is कृपया अपने विवेक का इस्तेमाल करें. Oh, not that Vivek. Okay, it just got better. This is a good Vivek to have. And do we have Vivek Gauri today join in the conference? That's another Vivek I was able to think of. I was fearing he might sneak in here, but this is the Vivek I'm talking about. Please exercise your judgment when you are making the moves. What I'm saying here should be generally good, but you have to take a call on your situation every time. With that, don't take that patli gali escape of where you're always trying to be that it's always the odd situation where you can't apply these learnings. So more or less you should be able to follow these good practices. They are industry established, and the uh, what the code conveys is very important in that respect. Okay, that brings me to the CPP, the C++ core guidelines. I hope you're all aware of the core guidelines. Just for, in case, I'll just give a quick introduction. If you just land on the isocpp.org, this is the website uh, of the ISO standard C++ committee. Okay, here if you land, you will see on the top there is something called as code guidelines, and that's the exact image which I had from in my presentation. These are code guidelines created by the likes of Bjarne and Herb. They started it, but there are so many numerous contributors to the core guidelines, and by some way or the other, even by raising a defect on things or by fixing a small typo, you can be a contributor. So please do think about contributing to the core guidelines. What they do is they mention of how to build a good an application which is based on good practices in C++. And so they are divided in several sections. You can go through it. They are long and there are many. Okay, it's not possible to know all of these, which is why I'm going to focus on just one of them today. Okay, and it's deep. So if you see, there are sections here: introduction, philosophy, interfaces, functions, about classes, enumerations, resource management, and you have it. So please visit and go through what parts. Start with what interests you. Just click on those sections. Think about go through the guidelines, some of them, and do mull over them and see how they can be incorporated in your daily work. So if you go to the philosophy section, there is So all these guidelines are numbered with the P dot 12345, and the interfaces will be named as I dot 12345. So the philosophy section is very general, and with general things there can be a lot of meaning attributed to things, and there could be a lot of depth in whatever is being mentioned here. So of this, express intent is the guideline that I'm going to talk about. Okay. So the guidelines are created very well in the format of what is the reason for what is the recommendation, uh, what are the examples, how is the enforcement going to happen. You will see there is an enforcement section, there are some notes, there are enforcement sections, and this is philosophy. If you see more concrete guidelines, you can see a lot of concrete sections which outline how it can be implemented and how it can be enforced, etc. Whether there are tools already uh, by it, whether it needs static or dynamic analysis, etc. And you can look at it. So the example which is dealt with here, I'm definitely going to cover in my presentation, and I switch back to it. So please do go through this. But the express intent is what we are discussing today. And while I present things, if you have some other thoughts or any things to add, please pitch in. No problem. So what do you see when you see this? What can you say about this code? Of course, the loop is not blank. It's doing something, but what do you guess it is doing? I'm intentionally hiding the loop part.
It may be
So
modifying the elements.
Uh,
iterating through the container.
yeah, iterating through the container elements. Okay, but you can't be sure. All you can say is it is iterating size number of times, and what it is doing, it's not clear evident till you actually open what is there between those braces
Container.
of the loop, and only then can you really be sure what is happening. Yeah, and don't know what the increment is. Very good point. So maybe it is skipping 5 elements at a time and then going through it. You can never be sure. The better way of doing it is to make it evident. Yes, maybe you are iterating over all the elements, but you make it evident this way. So at least now the increment is pretty much evident, and it is going from container from 1 to n elements of the container, right? Or are you? Are you sure it is going through all the elements? It is just doing something that many number of times. Can you still say what it is doing? Okay, you have to
No,
look.
the body may modify one anytime.
Sorry?
The body may modify the value of I anytime.
Who knows? Yes, right? So there, uh, it's not clear. Okay. If we have this, does it convey something slightly different to you? The eye is outside, it is traversing.
Yeah, it's the same.
No,
Is the
we
same.
need, I guess we need the index after the body breaks. We need the index of the last element where it broke. That's why we are declaring I forward.
Looks like the index is needed after the loop. Okay. That's why the person may have pulled it out. You can see it can be placed inside the if initializer, but it's not the case. Maybe the person wants to have the I available after the loop. So is he finding, is the code trying to find something in the container or something? Instead, if you had written this, you would be very clear that you are just so instead of index based iterations, uh, maybe this is a better way of saying. Here you are very sure of iterating over all the elements, and it is not just you're doing something n times, but it is just really iterating over the container. This is the additional uh, you know communication that this code is doing of its intent on of what it might be doing. Okay, on the top of the slides, I've tried to put the C++ version number. If there is nothing, like perhaps, oh, why is this C++ 11? Maybe by mistake. So this is forever there. This has been there in C++ forever. So I've not mentioned this one is wrong. I should correct it. But this one is C++11 because the range based for came in C++11. But if you think you are making element every iteration of the loop, right? This, I guess, now really tells that you are iterating over the elements of the container. In the previous loop where you didn't use the reference, you were making a copy. Maybe you were just taking the elements, creating copies and doing something else absolutely with it. It was just that the source was the value of the container. You were not actually working on it. You are working on a copy of it. That's what this code says. If that was not the intention, please be deliberate. And this is a very small mistake that hits you hard on performance. String reference is something that we should use instead of uh, hang on. Instead of just what do you say? Just having the data type. Okay, next. But really, were you iterating over the element? So what can you say what might be happening on the element inside the loop? Okay, you guys, I guess can unmute.
Might be doing
It's not
some transformation on elements, like lowering the strings.
Right, maybe it is changing the element, right? Because that's why you need a reference to that element. So maybe it is changing that element. But really, if that is not the intention, you need the const. If you are doing it just for efficiency purpose, don't drop the const. Remember, now this really says you're iterating over it to use it in a read only fashion. Maybe you're not modifying it. Okay. And you can write this by, so you don't know. So I did not communicate in this code what the container had, but there might actually be a conversion that, okay, if it was taking by value, there might also be a conversion which might be happening from the elements which are there in the container. If the container instead had just a const char, it was a container of const char pointers, it would be creating instances of strings from it in every iteration. If you have a reference, you have to have the reference there in the container for sure. And if you don't want to double state the same thing, you can just say auto element. And I don't know if the next slides for me says, yeah, the same thing becomes const auto. Now you're really sure it is going through all the elements and just using them as read only. And then you see this. Okay. Now it tells you that it is, anybody? You want to unmute?
It looks like a container that contains other containers, and it's trying to find an empty if the top level container contains an empty child.
Yeah. Usually when you are in a code, you know what the container really is. Sorry about slideware, but I also wanted to communicate the meaning because it is not important what is there inside the container. Yeah, so there is something in the container, the elements of the container may or may not be empty. And you're going all the way up to one which is empty. Okay, so looks like you're trying to maybe find an empty container, an empty item inside this container, or this code. Yes, Shaurya has a good point. I'll come to it. This tells you to go ahead till it is not empty. Okay, it is essentially similar to the previous one. But really, do you like to break things? You should ideally not like to. It should not be yeah, direction is declarative. programming. Yes. So you should state what you want to do. It should not be lost in the detail. Maybe you're doing something else before you hit this if, and something after also this, after this if also. And I have seen loops going up to, two pages or so, and you don't know where the bracket is finishing and how much is inside the loop and where a quiet break or continue has been sneaked in. It's not making it evident what it is trying to do. If you want to reach all the way up to the first empty element, you better state it. And that's what you should do. Okay. Sometimes we forget in the in the continuation and in an code base which you are maintaining over a long period of time, it just grows. And sometimes you think, okay, this is the best place to just break this loop, and you do it. But instead, I'm requesting you to stop and refactor the loop condition to really state what it is going to do. Okay, so you stop uh, at the first empty element. That's why the condition is go all the way till the end or until you find an empty element. So when you find an empty, you come out. Okay. And of course, if you use iterators, which for I named the container as container so far, but I switched to C, I guess. I switched to referring to it as C because of slide. So now we go based on iterator, and you have the iterator present. This is the whole reason why you would have the iterator declared before, so that it is valid even after the loop, and it is set somewhere inside the loop. Okay, and now you are actually using it. So the use is not muddled up with the looping. The looping really is just the looping, I guess. Hopefully it is empty. The three dots have nothing in them. And then it will be clear that it is just looping to find something. And then once you found, you only want to intend to use just one of the elements. But if you had everything up in the body, it was not making it clear what you're trying to do in this loop. Okay, so having the find and the use separated is a very good thing to do. It makes it clear and leaves no room for surprises. Of course, we have the standard algorithms coming in. I don't see much of this. We should try to use lots and lots of algorithms in the code. You don't realize how much opportunity we really have in the code. Just try to deliberately have pause and think whether you can apply an algorithm, because algorithms can be applied on any kind of data structures. The container doesn't have to be an std container. It could be your container. It could be an array with a list of pointers. It could be many kind of things. Do you know string is also a container? Std string is also a container. So anything you do with string, you could actually do with any of these algorithms. Some of the operations are there in the string as members, but not everything will be available of what you might want to do. So try to use them. And it says the container, the algorithm, what it gives you is a name for the operation. Once you look at findif, you really know what you are working on. And the reason this slide is marked as C++11 is because a lambda is used. If you don't use a lambda, which always existed since C++98, you could use any function object, and it might just work. So all you have to now pay attention to is the last parameter, which is the work which is done inside this find, or which is actually specifying the criterion for how you find, what you want to find. Okay, and here you're picking elements one by one as a const, and you just give true out of that lambda when it is really empty. This to anybody would mean absolutely the same thing, contrary to all those looping businesses which we have. And I want to remind you again of Sean Parent, who says no raw loops. This is the reason. There is a loop here, but now it's replaced by the name findif and by the condition of the if in that last parameter. So you can pretty much read it like, I call it reading like a newspaper, where you can quickly skim and still get all of what you wanted. You can leave the unnecessary details, like they say, X and X minister who is this thing in this location quoted this. You might just skip something like who it was and which location he said made the statement. You can just jump to the statement. That's how we read newspapers. This is what we should be able to do, because we do reading code most of the times of our professional life, not super typing 10x speed code, right? No raw loops. Yes, Ayush. So separating the use of what you found and the finding really conveys a lot of meaning. It makes the code clear. Okay. Now you might think this is too much. The condition here is very simple. The lambda is very simple, but you might think that it is too much, and maybe you could name that as well. Naming is a very good way of communicating the intent, right? So we just got the lambda out. It just takes some element and returns true when it is empty. Okay, and you see it is taking something by auto. So anything goes. In fact, this lambda can be used for different kinds of elements, right? Anything that has the empty function. So it's reusable, and that name sticks. And now your line reads, the second line reads so easy that it is finding if something is empty. Okay, so the first empty, when you find it, you want to use it. Somebody said something?
I guess someone's mic is on, so it's echoing.
Okay, no. Please mute if you didn't want to make a comment, or if you want, please, most welcome. Okay, so we have had Vishal Chowatia at CPP India. He has given a talk on algorithms. You can have a look at Sean Parents's talks on how you can really simplify your code with using algorithms. The talk is called as C++ seasoning. You have Connor Heckstra, who has also talked about algorithm intuition. So please go ahead and familiarize yourself more. The CPP reference is always there. Just go and try a new algorithm today. Maybe what you want is right there, named appropriately, and you have algorithms like remove copy if, and transform, all sorts of algorithms which work with one container, which work with two containers, and they help you do lots of things. Like you might want to add corresponding elements of two containers. Think about matrix manipulations, etc. You can do all of that with these algorithms. I mean, most of it. I can't say all. We are in C++. We don't make absolute statements. That's a rotate. Thank you, Himil. Yes, I should have quoted that. It's customary. Okay, if we look at further simplifying, essentially what you want to do here is just call a member function. If you see the previous, I've gone back a slide. This lambda is nothing but a wrapper to the class member. Do you think you're solving this problem for the first time? Most likely not. We should have this. You never got the. Okay, so Devashish asks that he never got the rotate joke. So Devashish needs to watch the C++ seasoning talk from Going Native 2012 or 2013 by Sean Parent. Okay. And somebody please share a link maybe in the chat. Yeah. So then you'll start getting it. He did some magic in that talk. It was lovely to see that. So coming back, this lambda is just a wrapper, only to be able to be called from this algorithm. And we are not solving this problem for the first time. We already have a way of getting a callable from in the standard library. Okay, we have member function, which can take a class, which can take any function. Sorry, a member function which can take any number of parameters. Our function takes no parameters, and we intend to pass no parameters to the function itself. We just need the object on which the member function has to be called. And this conveys much better than what the previous one was. Again, here you're lost in lambda syntax to some extent. If it is just not a return and a little more than that, maybe two, three things, it is trying to do some condition. You have to still go inside the body of that and then read it. It's not speaking to you. This is clearly saying I'm only interested in what this member function returns. And that's the condition, that's the criterion that I have for this find. Okay. Please use this. And note, in prior to C++11, there was something called as member fun, which was FUN. And in C++11, the fun got dropped. It was deprecated in C++11 and finally removed in C++17. So if you are in C++17 or newer, you will not have member fun, but please use member fn. And this is a better one. I forget what was the improvement, but I guess it was doing too much about unary function and binary function. Here it is deducing and detecting a lot of deducing all about the arguments, what is passed, what is the return result, and that kind of things. I think there they relied on some unary function and binary function templates, which took any function and figured out what were the two parameter types and the return type, etc. Here, it just within the template declaration itself, it is trying to do it. So they are not using, I guess, the unary underscore function and binary underscore function also, I guess, have been deprecated and removed already. But check the specs, check the reference. And I think there was an interesting point on why we need memfun, memfn. Devashish, why member fn is required? Is it because a type requirement for the findif argument? Yes. So what do we want there? So what do we want as the parameter, as the third parameter, as the condition for the findif? It has to be callable, any callable that can take the element which is iterated over. So whatever C has will be passed one after the other as the iterations go ahead to this callable. And to receive that, you need to be able to receive a type of object class. Okay, an object of type class. Okay, so this member function instead is a member function. You already need an object to invoke it on, and it takes no parameters. So it does not match. You just can't pass it. You need a callable. So whatever you do, I guess the standard memfun is doing something like what we wrote by hand on the previous slide. Okay, so you never have to write it, and it actually speaks for you. It says member function empty will be called, and whichever it gets true will be this. Will be found. Okay, now you have the iterator, and you can check whether you've actually found something and use it. Okay, thanks for the question, Devashish. Now, if you instead want to do something with all the elements of your container, you have the for each algorithm. Okay, so let's see what this code is trying to do. This code is trying to go through the entire container C for every element, for anything which is not empty. Anything which is not empty, it is trying to use it and also uh, print it in the standard out as a string. Okay, whatever use is returning. Okay, let's say use is just doing some transformation. I should have named it better. It is just doing some transformation and then giving back a string and giving back something which is convertible to a string. So a lot is happening here, and you have to read this again. So maybe standard algorithms don't make it that clear on what is happening here. So if you want to split all of this and do it all in terms of algorithms, because now if you see there is conditional, there is a lot of use. So how do you split it? If you want to use all standard algorithms only, you will now you have a lambda called as not empty. I'm talking of some intermediate vector. So I just copy if the elements are not empty into this intermediate into the intermediate container, and the back inserter inserts something things at the back. Okay, and Hemil, we'll go there. I'm not reading aloud what you said. So you conditionally copy all those elements which you are interested in. Now you have an intermediate container, and then you iterate over the container, and now you are sure that you are doing something to each one of those. So you are sure that you are picking elements which are not empty, and then you are using them and printing. Okay. I don't quite like it. All that temporary, intermediate vector and making copies and dynamic allocations will all come in the way. These are not things that we like. Okay. So C++20 gives us ranges. We have looked at this with Harishankar at CPP India Con 2 weeks ago. I'll just quickly show you what it is capable of. So algorithms are not composable. If you do copy if, you're just doing copy if. Then you want to change the element, the use can be a transform. Then you get something else, and then on that you want to do a toString. So if you have such a use case, the algorithms force you to create intermediate containers, have multiple iterations over the container that you're using, and it's good that the algorithms are there. They tell you what you're doing. You're copying elements selectively, you're traversing them, you are transforming them, you are converting them, but um, efficiency wise and code readability wise, it's not that helpful. So see how ranges makes it so evident as to what you're trying to do. We again have, we are using the namespace std views. I'm not showing any includes, etc. I'm not showing anything in my code except for a few lines. So you have the lambda as before, but now what you do is you create a piping. Exactly what you wanted to do was take an element, do something with it, do something. You could not go all the way, you could not do multiple operations on the element. Here what you are creating is a pipeline first. Okay, I'm deliberately calling it a pipeline. It's just creation of a pipeline. It's not a loop. It's not executing something. It's just creating some construct which can be executed uh, like something with a series of elements. Okay, so you start with your container. You say, like, you have Unix commands for all the elements of the container. You pipe it into a filter. What is it filtering on? Filter only elements. Give me elements which are not empty. Okay, so you don't want to use the elements which are empty, looks like, right? Then you transform it. Looks like you are going to change it. So you take these elements and you give me something back. Use will return something again, like we were seeing here on the previous slide. Use is giving something which you are converting into a string. Okay, here you are saying that whatever I'm getting from the left hand side, I want to transform it by calling this function on it, and that function will return something which will then feed into the next stage, which is converting into toString. Okay, now if you see, your loop says I go through the pipeline for every element. Once you pick up the element, you go all the way through all the stages that you wanted, and this is called as, we refer to this as lazy iteration. You define the iteration somewhere, but you're not iterating there. You are iterating in the for loop where my pointer is right now, and that's where you are picking one element going all the way through. Okay, so you're not picking the second element till you are done with the first element. Okay, and so this is super duper straightforward for anybody to read. Even if somebody doesn't know C++, can make sense out of what is happening here. Filter, and no, based on that condition, transform, which is to change the element based on this, and transform further to make toString out of whatever you get. And there are no prizes to guess. What is the input to this stage? Whatever the previous stage is giving. What is the input to this stage? Whatever the previous stage is giving. And you start with the elements of your container. This is what ranges do to your code. Make them so simple, straightforward, that you got to love them. So I can't wait to lay my hands on C++20. I hope you are able to switch to it soon too. And all the standard algorithms are available in ranges as ranges.
Ankur,
Yes, we are reaching. Dheeraj, we have lost you. I'm audible, right?
I hear you, but not Dheeraj.
Right.
Yeah, I hear you. Can you hear me? Am I audible?
Yes, Dheeraj, yes.
Yeah.
Okay. So my question here is this: if I create this pipeline, okay, so execute this pipeline for each element, right?
Yes.
It's one by one for each element. This pipeline will be executed. It's not like in a single shot for the whole something that
Yeah.
a whole for on whole container it will filter out all the non-empty and then transform them, and at a time it will give me.
Yeah.
It will one by one, right?
Yeah, this is like depth first. One element you take, you go all the way with all the operations. If you work with algorithms on the previous slide, I just switched back. This is breadth first. Everybody is copied. You do all these selections first. Then you have some subset. Then you do all the use. Then you have some subset. Okay. I tried to eliminate that again. Efficiency. I wanted to make the point. I should have used a transform algorithm here to use it. Then another transform algorithm to use the output of this stage and to give it into string. If you stayed with purely with algorithms, okay, that's the problem which ranges so easily and straightforward manner it solves. Okay, now I'm going to quickly switch into variables, I guess. Uh, guess what this variable is for. It tells you what it is for.
Max transactions.
Yeah, I think I should not have said C++ 98. That's incorrect. It is C++. I don't know, C front.
It's BCPL actually.
Aha. So,
Miss-
saying something?
So this max transaction can is not initialized here. What I can see.
Yes.
So it
Very good point.
contain.
It is, yes, very good point. It is not initialized. And what does it do? What does it mean? Any guesses on what it means?
Seems like a system where transactions are happening, so it's the limit of how many concurrent transactions can happen at some time in a given
Or is
period.
it or is it telling you the max limit of a transaction, like no transaction above 50,000 using UPI? Not sure.
Maybe.
Not sure.
Yes.
Will you see the value also? Now this gives you some indication that maybe it's money that you're talking about again. So I'm not specifying the domain here, but it's the transactions banking network, banking domain. I guess you can say it is on that. But so now you see 50,000. Now I guess still not sure. Maybe it is, maybe it's a limit of how much one transaction can be, or maybe it's how many transactions you can have in the system, right? But if you see the plural here, max transactions, now this definitely tells you something. Okay, by the value, you see it is a power of 2. Maybe it is restricting the number of elements somewhere. The plural tells you it is about many of them. Okay, and maybe naming it right again is a point which I want to make here. And always initializing the value is what always conveys a meaning. We were clueless on this slide, and sometimes we see it, sometimes especially with things which are marked as extern. We should not have many of them. Extern int max transaction. I don't like it. So it's like a redeclaration. That's why I don't like it. I'm giving you the reasoning also. Like you can have extern int, and in 4 different files you are having extern because you are not going to actually instantiate it. You are referring it to somewhere else. And if somebody changes that int to uint or uint64t, all these other declarations are not going to stay up to date. Okay. So having or not having plurals and everything conveys a meaning. That little letter S at the end change the meaning of the thing. Okay. Now, when you see both these together, definitely it is how many transactions you have somewhere in the system. Let's say you're calling it all transactions. So it is used to initialize an array. Okay. And but really what you want is call it const. because it's a fact of the system. Looks like array declarations don't change later on. Arrays once defined are always fixed with that size, right? So why not just mark it as const? Okay, execute this option. It tells everybody what it is about. Plus, it allows the compiler to optimize. This making it const makes it, even compilers can eliminate creating this variable in the first place. They might just use that value everywhere or do some other smart business, and there might just not be this variable anywhere in the system. Okay, but it is a good convenience. This is the zero overhead feature that C++ gives you. You are using a constant, but not incurring a cost or having the memory spent for it. Okay, and more often you might take this max from some configuration. Okay, so you have some config and you get the number of transactions max, but you take it just once. Okay, but hey, really, do you need this max transactions at all? How about just doing this? Because to be honest, who needs to know how many transactions are there in the system? If anybody other than this array needs to know about it, it might be a problem. Just the abstraction which just owns this array may at most want to know about how many elements are there. But clearly, you should not have to have the information about how many elements. It's like, okay, how many bank accounts you have, make it public. Why? Right? It's not needed. There is some hole there which you are leaving open for complexity to creep in, for confusion to creep in later. So don't have. I don't think you should need this. In fact, you could do that. Okay, and you read it from a config. You have this once, and you're done and sorted. That may be allocating once. Just like the array, it would be placed once somewhere. This would be placed once somewhere and created and initialized. And this is absolutely the same. And you get all those benefits of begin, end, and all those convenient things, convenient possibilities of adding and not, adding items and removing, etc. Algorithms apply, etc. If you come back to transactions, algorithms still apply to this. But do you know at this line how many transactions are created at the end of that definition?
One small thing, this array approach is not good also because the config can be anything. So if you have config is like 2 into 10 is to power 9, the stack will blow up and it will be a seg fault. So the better thing to do is to use a vector, because we cannot like config seems to be something that is set up from a file somewhere else. So if someone by mistake puts an invalid value, then it will blow up the entire program.
Makes sense. You have a point. So that's what the config.max conveyed to you, right? It's coming from some manually entered thing. And it's a very good point. Always validate the input which is given by a human or from another system, right? So very good point. But I guess I would say you might want to validate, because you might still have a real requirement of not having dynamism in the application. In case that is your case, don't have dynamic, but do the validation before you initialize this, okay? So really the point I was making here was how many transactions are created at the end of this that semicolon? Anybody?
No idea.
No idea.
No idea. All transactions are instantiated. There are n objects in that system, whatever the value of that number of transactions is there, so they are already created. Now that puts a requirement on the transaction. Transaction has to be have a default constructor, right? And it might not be a good way of doing it, because what is an empty transaction? It's a loophole for things to go bad. This array is putting a requirement on transaction to have a default constructor. A transaction without a value, transaction without a from and to account, hey, impossible. I mean, why have such a system? It takes you down, bad choices take you down the spiral of more bad choices. So don't. You create enough room with this vector, enough room to hold those many transactions, but they are not created. Only memory is allocated. They are created only when you actually insert elements into this. Okay, so that's a very big advantage. And having this once in the system, just like if this was a global for you and this is a global for you, you have no difference otherwise. And they are all contiguous. You have all the good benefits. Okay, now, of course, by the way, I jumped up one slide. This is also creating all the transactions because you said those many elements to be created. Okay, that's what this constructor does. It is taking a size and it will default construct all the transactions. Again, the similar problem. You get some conveniences, but same problem. If you do this instead, it is much better. Okay. But as you see, there is that dot 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 in the middle. If the declaration is somewhere and reserve is somewhere and you keep it somewhere in your initialization routine, you now have to have an initialization routine, etc., etc. Instead, can you not help yourself with just writing one small function which does these two things and gives a transaction? Is that creating a copy of the vector in the equal to? If
Depends on the C++ version.
Yeah, most versions were already eliciting this copy, but with C++ 17, it is guaranteed to not create a copy. Okay, compilers were good. You could do this. It was creating one copy, but hey, how many elements are there in this vector on a newly created store? 0, right? Okay, so in C++98, it was a low cost, even if there was a copy. Of course, if the memory allocation is huge, you have your choices. Again, take it with a pinch of salt. Vivek ka istemal kare. But all that validation that you wanted, that you talked about, Hemal, all the creation and initialization and getting the thing just right and then returning it is what you get. And make underscore XYZ, we are used to it now, right? Make pair, make unique, make shared from this. I'm not proud of that. But yeah, there you go. So that's the world. Nobody needs to explain anything, right? So there we have, life is much better. You could have an array if you really wanted really the array kinds, and that's where you can use a constant this way. And if it was a fixed size, right? At this point, you can't have a dynamic one because std array is a good wrapper over the old array, where the old array decays into a pointer when you pass around, and you just lose the information of that max, which is the whole reason why you had the max transactions. But with array, you always have dot size. It'll always tell you how many elements are there, and you don't need that declaration on the top. You can directly put the I hate to put the magic values, but yeah, hey, it should be coming from somewhere. If you just have a requirement of a function which takes lots of these transactions, maybe you pass all transactions or you don't. Or considering span is a very good way of referring to a lot of transactions. So if you just have a function which takes all of these, a container of contiguous elements, use a span, which came in C++20. Bjarne also talked about this in the AMA, and I'm sure you know about it. You have an implementation of it in GitHub. I have personally used it by Tristan Brindle, and he has a C++11 compliant std span, which does not let you your container decay into just losing the length, or even if you have an array, it would just stay. And this is dealing with contiguous ones, and just perfect. So you could pass a vector to it, you could pass a regular array to it, you could yourself pass an array and a length, sorry, a pointer and a length to it, and these are the only two things that this has, span has. Okay, and so you could pass std array, std any contiguous container, or any low level array like we saw in the previous slides, and uh, your code will support so many more types by just not taking a concrete type as a vector, but just by taking a span. Okay, and span is always, I think, sorry, I should not use the word always. It is usually passed by value because it is just very simple. It's a pointer and a length. You can see it decay to this very basic things. So it doesn't cost you much to just take that much and pass around as values also, because hey, couple of ints, couple of pointers, what does it cost? Absolutely nothing. Okay, and so If you wanted to only deal with the transactions and not modify them, you should say const span of const objects rather than just span. Okay, that's what this guy tells you. Okay, and if you worried about efficiency, etc., you would then come down to these type aware functions and implementations where you take something by moving inside. But this also gives a meaning that, now this guy is taking ownership of that entire vector and all the elements, and they will be gone. You don't have them now. Okay, so that's it tells the compiler, and there can be no mistakes. Like if you pass an L value to this, this won't compile. So compiler is always at your help. Okay, with that, these are some of the things which help express exactly what the functionality inside does, and some of the things which I wanted to go through. This is not the end of it. Expressing intent can be it is literally every line of your code, and I would encourage you to go to the core guidelines and read about it, and implement some of the things, or be deliberate about making these choices, and because har code ki har line kuch kehti hai. I think I should finish with that. Samapt. Dhanyawad. Any last questions?
I'll say this. What is the maximum length of a variable name that you will entertain? I'm asking this because when you showed the maximum transactions example, let me give the
Yeah.
So when you asked, when you wrote the maximum transactions, so Debashis had commented that we need a comment, and I was like, nope, we can just rename that variable to maximum concurrent transactions. So maybe the maximum amount that can be transacted in one transaction. That is an extremely clear way of like expressing the intent of that variable. But
Yes.
then, wait, let me check. Who was it? Someone, okay. Rishikesh had commented that wouldn't it be a big variable name? And I was like, yeah, but the linker is fine, and it express like the linker is actually linking the symbols together, so that's fine. And like my code is much more expressive that I don't have this ambiguity. So that the concurrent transaction is the amount. So
So the core
when to
guidelines
stop?
are usually about good use of the language, making the right choices, having the code communicate the right things. The core guidelines are not so much about naming and etc. So these are the things that people usually think of when they think of coding standards and code guidelines. But very clearly, the core guidelines state that appendix naming, okay, use this naming, but it's just encouraging you to do that. Now, what is a good size for you is up to you. Maybe you want to stick to a 80 or 100 characters in one line limit, and if you want that, you can make some of these choices and compromises on the names and lengthening and shortening of the names. If you have abbreviations in your code which don't mean the same thing to everybody, you have lost the point. Okay, you might as well struggle with the longer name than to be not clear. But if you have defined these things in your coding standards or in your guidelines, by all means, please shorten them. They are a good way. For example, having trans for transaction is good. TX for transaction may be confusing. It might be seen as transmit or transaction. Again, domain dictates what these two things mean, whether you're building a telecom software or banking software. But hey, who doesn't want to communicate? And let me tell you, in the telecom world also there are transactions. So we have protocols which have transactions. So uh, you have to decide things and clearly state these things which are somewhere in the middle or somewhere in the gray. Yeah, I will not take a lot of time on this point. Verbose costs, yes, verbose help and verbose costs. So it's a trade-off. Life is a trade-off. Any other last points? I guess we are almost done. Thank you very much, everybody. I would come back with a Express Intent Part 2. I hope this was
Okay.
something that you like to discuss, and I hope this was something which reminded you of some good practices. Every line, every word says communicates. That was my intent.
Yes,
Thank you very much for staying with me on this.